my research, which is shows social interaction in VR. Okay, so I'm going to talk for about 40 to 45 minutes. I do have to leave sharp 3 o'clock UK time, 4 o'clock Central European time, but I want to make sure I leave at least 10-15 minutes for discussion. So because I'm here to really, know how much what I said has, triggered thoughts from you and what do you think about it and everything. Right, so yeah, so this is me and the kind of work I've been doing for the past 18 years, I think. And that's kind of the structure of what I will be talking about today. So I'll be talking about VR for social interaction training, the first part, and then I'll move on to VR for neuroscience research, in particular social neuroscience research. And I will also talk about how do we make more effective social interactions in VR, and I'll use a piece of work we've done with the industry to illustrate that point. And then hopefully I will also have the time to talk about my thoughts about the future direction of VR and have a little discussion with you guys. But first I want to start with a very simple question. How does VR work? And before I explain that question, I actually have a question for you. And that's one of the reasons I need to see your faces as well. Which one do you think is longer? Anyone think the left-hand side is longer? Raise your hand. Yeah. Thank you. Okay, so I'm gonna play the video. It's a homemade video. I did it during my maternity leave because that's what you do when you have lots of IKEA train track populating your house and you have a sort of whingy baby there. You just started playing with real things rather than just sitting in front of a computer. So these two pieces are exactly the same length. And so despite knowing very well these two pieces are exactly the same, we can't stop feeling that the one on the left is slightly longer. And this is something called an illusion. And that's not a unique one. There are lots of illusions we see online, or in real life. So for instance, the first image, those lines, if you look at them closely, they're actually, the horizontal lines are actually all parallel. And then the second image, if you look away from it, you'll sometimes see the image started moving, but it's actually not a GIF, it's a static image. And then the third one is really weird. You just have to take my word for it. So the square labeled A and B are actually exactly the same color. You can do a screenshot now, and then use a color picker to, test if you get the same value. So they're actually exactly the same color, but it's really difficult, for me to even look at it and saying they're the same color. So there are many, many more examples you can find. I think these examples basically illustrate the point that our interface as human beings with reality is not as reliable and robust as we would like to think it is. And I think VR is just like an illusion like these ones, but it's supported by technology. So that's kind of the relevancy of VR and this. But with VR, basically what we do is through real-time tracking and real-time computer graphics, VR taps into our interface with reality. And that's the premises of a lot of work I do. And then by replacing the world we're in around us with the simulations in VR, it can trigger illusions that could challenge and reshape our beliefs of reality. So that's my definition of VR, but how does it actually technically work? And hopefully most of you have tried VR so far, but if you haven't, please do try it because it's difficult to really understand how it works, the magic of it, without actually trying it. But technically, this is how it works. When you put on the VR headset, 3 things happen, as summarized by Professor Mel Slater back in 2009. First, you have 3D vision, 3D stereo vision, because we have one different image for each eye. And that's easy, it's the same as going to 3D movies and stuff like that. And secondly, with VR headset, there's no escape. It's literally in your face. So you're kind of trapped inside the simulation, in a way, just like how outside of VR, we're actually trapped in reality. And third, but not last, VR provides something called sensory motor contingency. So in real life, as we move our body, our brain constantly integrates the visual input we perceive with the movement we're having. This is how we automatically develop our perception of reality. And thanks to the real-time tracking technology, together with real-time graphics, in VR, we can do the same. We can update the graphics according to our movement within something like less than 10 milliseconds per frame. This way that our movement in VR triggers a kind of visual input update. So we kind of have the visual motor match as well in VR. So our visual motor system works the same in VR as in reality, and that's how we develop this very strong illusion of being somewhere else in VR. And I have a funny GIF to show that as well. You can see this guy's having fun slashing cubes. But actually, if we switch up the VR side does look a bit ridiculous. So he is inside that illusion. He might seem a bit mad in real life, but his action makes perfect sense to him as he's fully immersed in this simulation. Okay. And personally, this is kind of my journey with VR. I started back in 2004-05. I made our first publication in 2007 with this environment I designed. I'm going to play this video, and hopefully the sound also works.
That shirt looks great on you. How much was it?
I think it was about 20 pounds.
Pay attention to his body language.
You look very nice too.
Yeah. So did you hear the conversation? Can you hear my computer sound? Yeah? Okay, cool. So basically, I'm just gonna play this again. So basically, she paid a compliment to him and he paid a compliment back, and he's swinging his body left and right. He's really enjoying this social interaction. And that's exactly the point that's exactly what we were trying to do at the time. So we wanted, to use VR to develop a social experience where we can have people to actually come in and enjoy. And the point is that we want to then to look at opportunities of using VR to actually as a way to help people who suffer from social anxiety to practice their social skills with virtual characters and really enjoy having a connection with a sort of virtual human. And then later on, when they're ready, when they build more confidence, they can probably then actually interact with real people. So that has always been kind of the, I think someone is typing. I can hear the typing sound. Okay, I'm going to move on. So that has been kind of the vision of my research, which is always about to use the power of VR to improve how we socially connect and communicate with each other. And this is because our mind is very complex, and during any social interaction, it gets even more complicated. So in real life social interaction, we connect with each other. Sorry, I'm getting a bit lost. I'm just changing the configuration of my computer screen now. Okay, so in real-time interaction, we connect with each other by exchanging lots of different social signals. Now I'm doing it online. You can see my facial expression, my gesture, but lots of them are probably filtered out. The spatial kind of connection I have with you, and also if my face is getting red, that kind of the blushing might be actually filtered out by the compression algorithm Teams is using, right? So lots of this is a very complex process when I talk to someone in real life, the kind of how we subconsciously exchange social signals. And this process can be quite overwhelming and even mysterious because lots of the social signals we're sending are subconscious. But then, the magical thing is that when two minds connect perfectly with each other is great. I hope you had experience of actually talking to someone and they're totally on the same wavelength, and you can really achieve a lot more than what you can do separately. But that is not always the case. And when you have two very different minds, this can make communication really tricky. For an example, when a medical doctor trying to explain very complex process to a patient, it might be really difficult because there's an imbalance in both knowledge and priority. For the doctor, it's just like this one thing they need to get out of the way and move on. For the patients, that's actually the only thing they've probably been caring about for days or even months. So even worse, sometimes you have someone maybe have a defective interface. They might have their brain function may be completely normal, but the interface is not working as effectively as other people or slightly different from other people. So for instance, someone who's suffering from social anxiety or autism, social interaction can be really hard for them or very problematic. So my vision has always been about that. I think we can actually use VR to solve a lot of problems we're having with social interaction. So there are three kind of complementary and iterative steps to tackle these problems. So first, I want to be able to provide using VR a realistic, safe, repeatable, and controlled environment for us to practice for trainings or therapy. And we've been working with lots of psychologists and medical doctors for this. And now I want to also be able to collaborate with social neuroscientists to use this kind of VR environment we develop as a tool to actually study the brain mechanism. Because as I said, we don't really understand social interaction, right? It's quite a mysterious process. So I want to be able to work together with social neuroscientists to use VR to study the brain mechanism behind social interaction. And then hopefully with the first two steps, I will be able to develop more effective VR and feeding back to the loops. That's kind of, how my research work. And today, hopefully, I'll be able to present 1 or 2 studies of each of these 3 steps. So the first one is social interaction training. So as I said, I've been working with medical doctors, really trying to solve real world problems. And the first piece of work we've done was done in 2015, 2014, and it was about unreasonable patient demand for antibiotics. So just a bit of a background. So overprescription of the antibiotics is a major contributor to superbugs. And superbugs is this bug that develop if you overuse antibiotics. And by 2050, if you don't do anything, 10 million people will die because of superbugs. So actually, it's more than people who are dying from cancer. So it's actually a big problem. And all the medical doctors in the UK, we call them general practitioners, or the GPs. They have the responsibility to not prescribe antibiotics when it's not necessary. But when we talk to medical doctors, and they said they actually find this process sometimes a bit difficult. They find it difficult to say no when patients are actually very much set on getting antibiotics. So I'm just going to show a video of our work. Right, I'm actually going to skip somewhere more towards the end here because it's quite a long video. Okay.
Rather than a bacteria.
Even if it is just a virus, isn't it better that we give it?
So basically what happened until this point is you have an elderly mother who's having a bit of cough. She came in with her daughter, and then the daughter has her mind set on getting antibiotics for her mother to get this sorted. And then the medical doctor basically was asking a few questions, and they were then convinced medically this is a case that antibiotics is not needed.
Antibiotics to help her immune system.
Well, unfortunately, that's not how antibiotics work. They don't. They don't boost the immune system.
Please, can you give us the antibiotic prescription now? And we will only use it if things get worse.
As I say, I don't think that's necessary right now. Sometimes we can do delayed prescriptions, but I've examined your mum right now, and she looks fine to me. And I think this is a virus.
Doctor, maybe you can give us a prescription, but we will only collect it if my mum gets worse.
Okay, it seems like that's something you're both absolutely fixed on having. We can arrange for a prescription that you can pick up tomorrow or the next day if things are getting worse.
Reassuring as I can, I do not think that there
This
is...
is so unfair. It's going to ruin our holiday. I'm going to take this up with the local health authority. I think you are unfairly denying medicine to my mother.
Okay, I appreciate your concern. Thank you for your feedback. I do think that the best medical practice at the moment is to manage this conservatively for now.
My mother worked and paid national health insurance all her life. Now look at what's happening.
Sure, I mean, this has got in no way...
Okay, I'm going to pause it here. So now you all know how to get antibiotics from the UK medical doctors, but please don't. Yeah, so basically we did a study with 21 medical doctors in total, and all of them knew that these are not real patients, these are virtual patients, and they knew this is a medically clear case of antibiotics shouldn't be prescribed, and that was like their first reaction from the video anyway. And they know they're being videotaped and evaluated for what they do, right? But still, out of the 21 medical doctors in total, I think I have the result in the next slides. So we actually divide them into trainee GPs, 9 trainee GPs and 12 more experienced GPs. None of the trainee GPs managed to say no towards the end, and only 4 out of the 12 experienced GPs said no. So it was actually, we were surprised by the result. We thought, come on, you're medical doctors, you're trained to say no in these kind of situations, and you know all the right thing to say, but actually most of them actually gave up. So some comments: they felt stressful, as I felt the characters were putting me under pressure to make a decision to prescribe. Really useful for testing how you respond to difficult situations. Yeah, so we had lots of positive feedback from the medical doctors we were working with. And that's how we then started the second piece of work in the area of child safeguarding concerns. So again, a bit of background. So child safeguarding, basically as a primary contact for families, you don't normally just, so GPs, medical doctors, as in the general practitioners, play a very key role in raising any safeguarding concerns. And you do have child safeguarding concerns issues actually raised in A&E department. But when they ended up in A&E, it's already too late, right? So all the general practitioners, they have the responsibility to raise concerns as soon as they spot something that could be going on, right? So they have been all trained to do that as well. And that's something they also raise, that it's difficult to practice in real life with actors, because you can't really tell a child actor to act as if they've been abused. It's really, really difficult to do. And then for this work, we collaborated with Professor Caroline Futterman, who is a consultant pediatrician from the UCL Medical School. She's also one of the co-authors of the Child Protection Practice Manual. So this is one of the animation we developed together with her.
He'll be quiet, right, Tom? Tom, sit here. I don't know what's going on in this boy's head.
So the dad was just trying to gesture, but the child ducked his body away. And this is a cue that all GPs are trained to watch out for. So like when you have like physical contact with your child, if you have a history of being violent towards the child will automatically duck their body, right? So we had a few cues like this in the experiment. I'm going to show a little bit of video of how it works. So basically, we have the father coming in who has a medical condition, and then the medical doctors have to focus on the father, but then the father also came with the child, right? So.
You'll be quiet, right, Tom? Tom, sit here. I don't know what's going on in this boy's head. Oh, dear. I just really need to talk to you about what to do about my, I don't remember the vow. One of them now. It's a bit sticky, I think. And what could you not? I don't really understand my options, so I've got to make a decision now, like this week. Otherwise I'll miss my slot, you know what I mean?
One option is to have surgery through the chest to replace the valve, and one is
yeah, that's open heart surgery.
Exactly.
It'll open me up.
Exactly. And the other option
So basically here, what's going on? Sorry, I pressed the key and then my browser just went like completely mad. No, I don't want to do this. Sorry, I want to see my notes. Okay, sorry. So basically, the father came in with a very complicated problem. So that was intentional, because we want to make sure the GP is under very high cognitive load. And we want to see, when they're dealing with a sophisticated situation, quite challenging for themselves, do they still have the capacity to actually identify there's something potentially wrong, right? And I'm just going to try to go towards the end of it. So the father actually left halfway to pick up a telephone, and then in the end, the father just left. And then we tell the participant to just do what they normally do in a normal consultation, which is to type up the notes on the laptop in front of them. And that's why we run this experiment in the cave-like system rather than with the HMD, because lots of medical doctors complained with our antibiotics experiment that everything felt very real, but they didn't have access to a computer and they couldn't type up their notes there, right? And they found that a bit unrealistic. So in this case, they had access to a laptop. Okay, so that's the setup for the experiment. Okay, so here are our measurements. We use the dependent variable note, which is basically the note they type up on their computer. So we ran about 63 participants. They're all medical doctors. And then we gave their notes to 10 independent raters. They then go through the notes and then give a score of the notes between 0 to 100 of how much do you think the notes has shown awareness of child safeguarding issues and the development of some strategy to address those concerns. Okay, right. So when we also had independent variables, which is the stress level, it's a self-reported stress level before the consultation, and then their personality as well. So interestingly, with as expected, with perceived stress, we have a negative correlation with notes, which means that the more stressed the medical doctor reported himself to be ahead of the experience, the worse the quality of the notes were. And you can see some notes received a record of 0, right? And that's the medical note where they didn't even mention there was a child in the room, right? So that's just quite interesting. So I think this is really useful guideline for the government. Really, it's like, don't get your medical staff get stressed because they will make wrong judgment, and later on all this will actually come with a greater cost, right? And we also have done the correlation with the personality Big Five as well, and we found there is a positive correlation between note and agreeableness and extroversion, but there is a negative correlation between the note and neuroticism. So maybe that's also useful. So if you want to actually train doctors to do better on these issues, the ones who are more agreeable and more extroverted, they probably need less training. But the one who rated higher on neurotics, they might need more help in this area. Right? So that's kind of useful findings, which is otherwise difficult to have without the use of virtual reality. And and some comments. Impressed evoked a sense of discomfort within me, which is difficult to do in an artificial setting. And all of them are commented on they'll be really useful as a training tool, particularly with regards to difficult consultations and breaking bad news, etc. Okay, so that's kind of the work I have been doing, work I've published already in this area. We have some more sort of interesting work coming now. And this is in collaboration with the Great Ormond Street Hospital for Children, which is the biggest children's hospital. I can't tell you more what this work is actually about, but I just want to show you this clip so you get a sense of the quality of animation we're dealing with now, because things are really progressing very quickly in this area. So in this case, we worked with professional actors. We used our own motion capture equipment at the lab. I think it's an OptiTrack system. And we also recorded the facial expression with an iPhone-based system as well.
This is happening today. I am not going home today. Now, I don't care about the other patients. I'm sorry, I just care about my son. Are you saying that my child is not a priority? My boss will not care. I'm going to get fired. I'm going to get fired because of your mistake.
So I think there's lots of things quite subtle, we're able to capture. And this is something we did this summer, and things are just constantly moving on in this area, right? So it's still kind of far from the sort of Hollywood production level, but in-house in the research lab, we're now able to have animations like this. And hopefully, we'll be running the experiment soon, and then hopefully I'll be able to report soon on the result of that experiment. So that's kind of the first sort of part of my research. We also have been working with social neuroscientists on actually understanding social interaction using the power of VR. And for this work, mainly my collaborator is Professor Antonia Hamilton from the Institute of Cognitive Neuroscience, UCL. And the study I'm going to show today was actually done through this system on the left-hand side, where you have participants sitting in front of a computer, and we use the behemoth, which is a magnetic tracker, to track their head and hand. And instead of a proper sort of immersive VR system for the work I'm presenting, we're using kind of a big projection system. So it's a bit like extended reality. It's like you're sitting on the table, and on the other side of the table, there's a virtual character sitting there, right? Okay. So before going to that work, I want to do a task with you. So if you can have your hand like this, just exactly like the image is showing, okay? And now, as soon as you see this, try to do the same, okay? Okay, so hopefully we can all do it very quickly, right? But now if I tell you to still open your hand, okay? As soon as you see this, okay, try to do it, but open your hand as soon as you see the fist figure. Yeah, you can still do it, but I can already see it's probably a bit slower than the first one, right? You can try it again, but yeah. So this is something called mimicry or automatic imitation. And it was first reported by Hayes, etc. in 2004. And basically, where I told you to open your hand when you see this image as a congruent condition, and left-hand side is an incongruent condition. And it turns out all of us are going to be quicker in copying the congruent condition rather than the incongruent one. This is a mimicry effect. And this kind of behavior is summarized by Bach and Charand as the unbearable automaticity of being. Basically, we all have the tendency to copy the action from people around us in many different ways. So in other words, we're not really in charge of our actions as we would like to be. But it's part of evolution. There are reasons why we have the tendency to copy actions and decisions of people around us. And actually, automatic imitation is often referred to as mimicry, which is defined as our propensity to implicitly and automatically copy the detailed kinematic features of an observed action rather than just the goal of an action. And there is another process which is called emulation, which is sometimes we also copy the explicit goal of an observed action. And this is the framework proposed by Antonia Hamilton back in 2008. She thinks that basically we would observe an action and there is a mimicry sort of pathway which from what we see, the features we see just directly drive our motor action. But there's another pathway which we see people doing things, and then we try to summarize the goal of the action we see, and we might even update the goal to our own goals, and that then also are expressed with our motor movement. Right, so there are these two pathways. One example is like, for instance, if you're in a meeting, I see someone grab a cup of water and drink some water from the glass. You might actually do the same, and then you drink the water and you think, oh, keep me hydrated is a good thing to do, right? But if you see someone reach out and grab a can of Coke and start drinking, you might also reach out your hand, but then you might stop halfway thinking, oh, I shouldn't really be drinking Coke. It's not very healthy and it has too much caffeine and it's quite late already or something, right? So this is kind of an example of how the mimicry pathway and emulation pathway could work together, sometimes arrive at the same outcome, or sometimes the mimic pathway sort of triggers action first, but then your action get alters when you arrive to some other conclusion with a slight delay. So normal people have a good balance between these two pathways, but the theory is that people suffers from autism actually have an impairment in the mimicry pathway. Okay, so we then try to test this with virtual characters, because that's a theory. It's actually not very easy to test with real humans or with videos, because video doesn't feel very realistic. Where real humans confederate, it's difficult to control everything they do. So in this case, we use virtual character to try to study this. So here we use the actress and we use the motion capture system at lab, which was the Perhimas magnetic trackers. We just put a sort of tracking on the head and the little finger of the sort of index finger of the actress. And then what we told her to do is to, she has 4 dots in front of her and she just have to go through the 4 dots. She's going to choose 3 of them each time. So she can do 1, 2, 3 or 1, 3, 4, right? But we recorded all these 16 different combinations. We recorded them twice. The first time we told her to do it with a low trajectory, and the second time we told her to do it with a high trajectory. Okay. And then we invited both neurotypical and ASD participant to come here and do the task. The task itself, we just tell them to copy the goal of the avatar. So we say, if the avatar does 1, 2, 3, you also do 1, 2, 3. That's all you need to do. Okay. But then what we were hoping to see is that by copying the goals, people would also automatically copy the trajectory, right? We didn't tell them to copy the trajectory, but we think they would. And that's exactly what we found in the result. So NT is neurotypical, and you can see that with the high trajectory avatar, the participant's peak height is also higher on average, and that's significantly different from the avatar who has the low trajectory, right? So that's strong evidence for automatic imitation. And for ASD, this is also the case. People also had a higher, the movement, the height of their movement is also influenced by the movement, the height of the movement of the avatar, but the difference between the two is a lot smaller. So there's an interaction effect here as well. So basically, in both groups, there's evidence for mimicry, but there's also evidence that people with autism mimicked less. Okay, so that's kind of confirmed what we were trying to find. But at the same time, we actually also had another condition where we actually had two different avatars doing it. One avatar is engaged, the other one is disengaged. Right, so one avatar will be like, oh, let's do this task, and I'll be looking at you. And because the participant is wearing the head tracking, so the avatar can actually just follow them with their eyes as well, give you a strong feeling she actually cares about what you do. Where the other one is like, oh, let's do this task, but I have something else I'm looking at, so she's not actually looking at you as you're doing the action. So our hypothesis here is that at least with the neurotypical participant, this more engaged avatar will actually trigger a higher kind of level of mimicry. Right, but what we found is not the case. So with neurotypical participant, the disengaged avatar actually triggered a bigger sort of difference between high and low here, which is opposite from what we were predicting. Obviously, the effect is not significant, so it could be just by chance, but we didn't find what we set out trying to find. But we think one of the reasons is that we didn't actually do this experiment in a proper immersive VR setup, right? So maybe people are too much influenced by the fact they're observed by the experimenter rather than this avatar who either pretend to or not to be interested in them. And secondly, although for the engaged avatar, although she's looking at you, but she's not really reacting to you. Do you see what I mean? It's like she doesn't have any level of intelligence. She's not an AI. The only thing she's programmed to do is to look at you. So we think maybe the future sort of improvement for this work is to really program the avatar for her to be more reactive, to be more engaging, right? So that could really change the result of this study. Okay, so that's kind of the second part of my work, which is social neuroscience research. And now I'm going to move on to talk about the more effective VR. And actually, that's kind of the result. So one of the problems we had with medical training experiment as well is that we kind of use this Wizard of Oz setup. So we have basically we pre-record everything, and we have an experimenter sitting in the room triggering all the events, right? And the avatar are programmed to kind of look at you, but that's it. We don't have any other features. And the same with the social neuroscience research. As I said, the engaged avatar didn't actually maybe is not as engaged as we were hoping she is, right? So for the more effective VR part, one of the tasks is like, okay, so from what we learned from the previous two steps, we really need to be able to integrate machine learning in our future work to really program avatars who react to you in real time. So we've done some work, part of the work is about actually understanding real life social interaction by just getting all sorts of multimodality data from participants and try to understand how turn taking and gaze actually work in a real life situation, so that we can probably use hidden Markov chain or other machine learning models to get our avatar to do the same thing. But today I want to focus on a piece of work we actually did with the industry, which I think is really interesting. So we were so as I said, we kind of collaborate with lots of people. We collaborate with medical doctors, with neuroscientists, with psychologists. Being based in London also means that we have lots of amazing sort of creative talents like XR studios, game studios, who we can work with. And we were fortunate enough to win a grant where we were working with the game company who was doing the VR game for Peaky Blinders. Does anyone know what Peaky Blinders is? Give me a raise of hand. Okay, so it's almost like this is like my question to test how British you are. So basically, you might be, not in Britain, but if you care about the British culture, you probably know about this. If you don't, then you probably don't care about British culture. It's just like this TV series that everyone in the UK knows, but not so popular elsewhere. Right, so it's quite a sort of, interesting creative piece. And we were able to work with two game companies, Maze Theory and Dream Reality Interactive. They were kind of both quite small game studios, but they have lots of really amazing creative talents. And that's something I found quite amazing working with creatives in the UK is like a lot of the great talents actually work in very small studios because they prefer that kind of more flexible, smaller environment where they can be in charge of what they do, their creative freedom, which is very important to them. And then the UK government is actually really great at supporting this kind of work. So we have the Innovate UK and we win a £500,000 grant to exactly support this game studio and our collaboration with them to create AI characters, which will make that character a bit more connect a bit more with the players. Okay, so just a bit about non-player characters, if you are not familiar with sort of gaming. So normally applications in gaming in this area, you don't normally get to interact with the virtual characters in a very sort of how to say, intuitive way, right? So sometimes you can have a conversation with the virtual characters in a game, but normally she would say something and then you would be then provided with 3 options and you're going to have to choose one. Now we call this explicit interaction. And as VR researcher, you know, I'm very much about the illusion we try to create in VR. And I think this kind of explicit interaction really breaks the illusion. It really reminds you that whoever you're interacting with, they're not real, right? And so basically for our work, we want to be able to find ways where we can be more implicit in capturing the user's status and then to program the avatar to be more reactive, right? Rather than the users pressing a button. We want to use something they already do in a normal social interaction to trigger this. And we had various workshops. It was actually, you know, it wasn't a very easy journey because in the beginning, we all come from a different background. The game creatives, with the language they use, the way they think is very, very different from us. So it's really through many sort of workshops, and we use post-it notes, and that's another kind of advantages working together. I think like for people who come from very different backgrounds, there's definitely big advantages to be in the same physical place, so that you can, you know, can have a shared space, you can have some small activities, and that's how you can connect and actually willing to talk to each other. So we have some constraints from the game developers, which were highlighted in the very beginning. So whatever we do has to work with existing VR HMDs, and it was work done by at around 2019. So at the time, it was just like really sort of the Quest 1 kind of thing we're looking at, because they want their game to actually go into a big market, right? So if you limit it to sort of PC rendered AI, then it won't work for their game. So we have limited power, also have limited tracking capacity. You know, we can't use any of the fancy trackers we have in the lab. It has to be whatever is available in a consumer VR headset. And yeah, we were also told that yes, we were thinking, oh, maybe we can do like yes or no, and you know, this kind of simple sort of triggers. And then the game developers are like, no, game players don't talk to virtual agents. Just forget about it. We can't risk asking them to talk to virtual agents. So it's okay, fine. Point taken, right? So then we've decided, but we still want this interaction to be very implicit. And then after a few rounds of workshop, we decided we can actually use users' body language captured by VR to try to gain trust from the virtual agent. And if you have watched Peaky Blinders TV series, you know it's actually a lot of it. There's a lot of monologue of, you know, just great actors, you know, giving a really nice monologue. And there are lots of the sort of plot development is about gaining trust from another individual. So we use this basically as the way we design our interaction as well. So I think I actually have a video. Right, I'm going to play the video. Do I have sound? Sorry, let me just see. Okay, I have sound.
It is a thing of beauty.
Right, I want to be able to, yeah.
Isn't it? When I was small, my mother would wind it up for me before bed. I'd listen to its sweet melody till the twinkling rose-tinted finch cast a dreamy blanket over me. What's got to do with my uncle? I shouted.
Okay, so that was, sorry for this again. Let me see if we can get this to play. Okay, I think, so that was the first participant, and I'm now going to show you another participant. Hopefully the video is gonna play. Okay, I think it's going back to the first again. Let me try to escape. Right, it's not really working, and I don't have the bar that I can change. So let me try to see if I can play it here. No, it doesn't allow me to play. Okay, I can't show you the video. Sorry about that. My Google slide is not working. But basically, the video I was going to show you was this two participants listening to her giving a monologue. She has actually a very complex storyline, which was written by professional scriptwriters. We actually did another workshop with them, and then they come up with this really complex story, very emotional and everything as well. And then we get people to come in, and then the video I was going to show you was the first one was basically looking around, not really paying attention to her, where the second one was like completely in front of her. Whatever she said, he just nods, and at some point he even tried to tap on her shoulder because she was telling a really sad story, right? So what we think is that we can actually, by looking at these people's behavior, we can actually judge whether they are paying attention, they're socially engaged in the conversation or not. Okay, and that's basically what we try to do here. Is we think that we can actually so our judgment of social engagement, which is a social attitude of other people, is based on very complex behavior, and some of them are very subtle and subconscious. And we might even have very different opinions on the same situation. So the reason why I wanted to show you the video is I'm pretty sure if I have a share of hands, not all of you would agree, which is actually really interesting. And so this is so social engagement is actually quite ambiguous. And what we try to do is like we want to preserve this ambiguity, because we think what's important, especially after interacting with the game creatives, is that whatever the creative director, Ross Harding, whatever his decision is, that should be incorporated in the game. So ideally, what you should do is that someone playing this game, Ross can be there in the room, looking at them, saying, "Hey, you are actually paying attention to the avatar, and I will give you the trust score and for you to pass to the next level." Right? That's the most ideal situation. But obviously, we can't have Ross in their living room when they're playing the game. But what we try to do is, can we actually use the signal that's captured by the VR system? To actually capture enough information and then train a machine learning algorithm to make the same judgment as Ross. Okay, so we get about, I think it was 17 participants to go through the experience. And then instead of letting Ross just watch the video, we actually think, okay, if we're going to train a machine learning algorithm to try to understand the data, we need to let Ross also see the same data as the machine learning algorithm sees. So we get Ross to go into VR and then actually watch the interaction of the participant represented by this kind of gray figure interacting with the avatar, and then let him label the data we collected. So basically the pipeline is that you have the user, they have basically the two controllers and a headset. So you have 3 of the 6 degree of freedom data point you're getting each frame, and you also get the data from the VR scene, the position of the avatar, what they're saying and stuff like that. And then you can then you recorded all this, and then you can have Ross actually labeling whether they think at this moment the user is engaged or not. And he'll press plus or minus, depends on the judgment. And then we then give this labeled data to our machine learning model. So basically we're able to train our machine learning model to make the same judgment as Ross would make. And then we can then use the labeled data to maybe drive direct interaction of the avatar, or maybe whether the user then able to go to the next level or not. Okay, so, and also the creative director was actually too busy for this course, so he couldn't go through the label process. And we had our PhD student, who is also a VR interaction designer, to actually be the one who labeled the data. Just, realistically, that's just what's going to happen when you work with game companies who are super, super busy and have lots of deadlines. Right, so this is another video which actually shows the process. I think this is will be a lot better than what I have.
We can understand how humans interact with each other and can say, from their body language, whether they are socially engaged or not. In virtual reality settings, this helps maintain plausibility illusion, but it's difficult to implement, as our judgments are subconscious, so we cannot come up with a set of explicit rules. In this work, we collaborated with 2 game studios and developed an immersive machine learning pipeline for detecting these kinds of human-defined social attitudes in VR games. First, volunteers took part in a social interaction with a virtual character. Next, an expert annotated the social interaction in the same immersive medium. This data was then used to train a machine learning model. We considered different model configurations, out of which the one that is pre-trained and with a temporal memory performed the best. In terms of input data, we trained it on raw features, such as head position, as well as psychologically based features, such as the distance between the user and the character. The model using the raw features could not generalize to different virtual character positions, whilst derived data performed with 83% accuracy. This work contributes to the field of socially responsive virtual characters, offering a design-by-example tool for immersive machine learning, to detect abstract social attitudes in VR social interactions, and allowing future VR games to be more engaging, immersive, and inclusive.
Okay, so that's a summary of that work. I'm gonna try to. Okay, so that kind of summarizes my work. It's really about to use the power of VR to improve how we socially engage and communicate with each other. And because I believe good relationships and good social interactions are, really, really important for our everyday life. That's what makes life enjoyable and meaningful and makes us happier and healthier. And this is actually backed by science. There's this study, I think, in Harvard that lasted for over 80 years. They found that the strong relationship is the far and away the strongest predictor of life satisfaction. And that's and better predictors of long and happy lives than social class, wealth, fame, IQ, or even genetics. And I think, I think having sort of high quality social interaction should be a goal for everyone. And I think VR could be playing a very big part of it. So that's kind of the key part of my talk. Just want to spend the last couple of minutes talking about what I think is going to happen for the future of VR. I start this figure, which is from 2004, is how computers see us now. I think we spend so much time on, on a flat screen, on mobile phones. So for computers, we normally have stereo audio, so we have 2 ears, one eye because we don't have stereo vision on computers, and we just have one finger to click the like button or make a purchase, right? So that's basically what sort of modern computer is turning us into. But this is who we really are, not as pretty as we hope, but this is the sensory homunculus created by Penfield in 1937. There's a very similar, I don't remember whether this one was the haptic one or the motor one, but the two are actually very similar. And I think VR is a way to kind of bring us more towards who we are, because in VR, the interaction is 3D. And I think importantly, if we kind of focus on this figure, the big part of this monster is the face and the hands, right? And that's, I think, where research in this area should be focusing on. And actually, for VR, that's already sort of happening because like we did this work last year at Entropy VR. I think I just want to do the facial expression part. I can find it. Yeah, I think it's here. So basically, with HTC device, we can already animate the facial expression of our avatars in real time. And with the Meta Quest Pro, you can do the same as well. And it's not actually trivial. It's actually quite difficult to get a facial expression mapping right because you don't look exactly like the avatar you're using. So there's actually lots of research to be done in this area. And another area I think is, the character has a big face and a big pair of hands. I think there's a lot to sort of do research on in that area as well. So we've been basically looking at haptics, and this is the tuttling effect of, so when you hold, you see yourself holding a stick in VR, you see a ball jumping, we'll try to understand the psychological sort of impact of that with haptics or without haptics. And we also recently published a paper in ISMA, where we were comparing hand tracking and controller tracking. And interesting if you kind of look at the correct pattern only one. So basically, they were playing a memory game, and with hand tracking, they were doing a lot better, significantly better than using controllers. And this is because we think using hand tracking, because then you have the consistency of the sort of the image of your hand you see and the actual hand post, rather than using controllers where there's a discrepancy of your hand gesture and actual sort of image you see. That creates a cognitive load. And without that cognitive load, you're able to perform on a memory task better. But we also found that with hand tracking, another thing we didn't expect to find it, we just kind of measured it anyway, that people actually use their two hands equally. So when you use controllers, you turn to rely everything on your dominant hand. And that's what we tend to do when we have a task we don't feel that we're in charge of. We rely on our dominant hand. But when we actually use the hand tracking for a small task, quite simple task like this allows us to use both hands almost 50%, which I think is actually really important for user interface designers to consider. Yeah, and this is our lab. So I lead the lab together with Professor Malcolm Gillis, and lots of work you've seen are done by these amazing researchers, PhD students. We collaborate with lots of different labs around the world, and we also collaborate with companies, medical doctors, and creative studios, which has been really fun. And we also enjoy meeting with each other in real life as well. So if you want to collaborate with any of this work, I also should mention that we run a master degree in AR and VR. And in the UK, we have those kind of 1-year master degrees. So our students are very much trained in sort of programming, VR design, using the equipment, tracking and everything. And they are doing their project every year from April to August. So lots of them, so if you have a project, you want to do a prototype of something, we have lots of students who will be very interested in working with you. Okay, thank you. I think that's everything I wanted to say.